Hi, this is Peter with his Awakening channel. Today we are talking about the moon, which is supposed to be 384,400 kilometer distance from Earth, which I personally do not believe. I'd rather think it's about 1,000 kilometer maximum. But anyhow, you can see a crater on the moon itself, which is called Tycho Brahe. Tycho Brahe was named after a famous Danish astronomer from the 15th century. Tycho is about 43 kilometers in radius, which results in 272 kilometer circumference. Now, how do we get that? We can see that by zooming in, that you can do yourself with your Google Earth program. Here we go. Now, in order to have a good comparison between Tycho circumference, I have chosen an island nearby where I live, which is Bali. It is called Belitung Island. Belitung Island is between Sumatra and Borneo or Kalimantan. Now, let's have a look at this. I type here in Belitung Island, so it's easier to zoom in rather than having to search everything. Now here we go. Okay, so that's the island I'm referring to. I have never been there, by the way, but it must be a nice island, not very much inhabited. Now, let's see first the differences. I mean, to prove to you that it is basically the same diameter and the same circumference as Tycho crater, so that we have a good comparison. Here we go. Here's Tycho, and here is Belitung Island. Here you can see all the details. Now let's go into Google Earth again and look at the eye distance. Now, something is really wrong with Google Earth, because in my opinion, it does not represent the real distances. But anyhow, this is about the distance what you see when you fly by plane over the island. Now, if we zoom out and go into the distance which we are supposed to be from the moon, you can't see anything at all about the island anymore. So it must be totally wrong what we are being told. Okay, let's go to the next subject.
When something is round and too far away from you, you cannot say what shape it is. It can be a flat plate, it can be oblate, it can be concave, it can be a sphere. You just can't tell. Here are 4 objects. They all look round, right? But are they all spheres? How would we know? What if I told you that there is only one object that is not spherical? Can you tell what it is? Can you tell me how you knew it? How would we even know the distance? I can tell you that they are 100 feet away and you will believe it, but they can only be a few inches away.
And I can tell you that they are 10 meters in diameter, but they could only be 5 centimeters in diameter. You can never know using your camera.
Please look at them carefully. Here is the only object that is not spherical here. Here it is. I bet you thought it would be another one. But it will blow your mind if I tell you that this second object is also not spherical, and it's flat. And it will blow your mind even more if I tell you that this third object is concave. But how about this one? This is the only spherical object. We could have an oblate object and you would think it's spherical as well. So looking at something round does not mean it's a sphere. Have you ever seen the moon rotating in the sky? You have always seen one side of it, which makes it impossible for anyone to say the moon is spherical. However, using the word round is correct. A plate is also round. Look at this moon right here. Does it look round? Yes. Does it look like a sphere? Yes. Is it really a sphere? Let's find out. Well, it's not. It's flat. You got tricked again.
Mainstream science will have you believe that the craters on the moon are due to impacts from meteors, comets, and asteroids. They will have you believe these thousands and thousands of circular craters which cover the moon's surface are all due to impacts. Now, anyone who wants to make sure that this information is correct can Google craters on the moon, and they will tell you straight away lunar craters are impact craters on the Earth's moon. The moon's surface has many craters, almost all of which were formed by impacts. So when I zoom in on the moon and I take a close look, I can see all these circular craters which they say are from impacts. My question is, if all these space rocks are flying in at different angles, not just 90-degree angles, where are the impact marks which create digs and canyons and trails? Shouldn't there be meteors and comets and asteroids coming in at various angles, all sorts of various angles, which should be hitting from the side and creating canyons, dig marks, scrapes, gouges? Are we to believe all of these meteor impacts are coming in at 90-degree angles? We should be seeing marks like this on the moon. Like I said, dig marks or scratches, scrapes if you will, caused by meteors coming in at an angle. I can find images produced by Hollywood which demonstrate this, where a meteor comes in at an angle and makes a big giant gouge, right? And digs deeper and deeper into the earth as it hits. Well, in this case, we should be seeing these marks on the moon, except we don't. And if you even type in meteor impact marks, all they show you is a bunch of images of meteor crater in Arizona and a bunch of circular impact marks. I can't even find the right verbiage. I put meteor impact trails, and then they show me trails left behind a meteor in the sky. So I can't find any actual images to display this in real life. All I could find were these Hollywood images of meteors coming in at an angle and making these gouges, scrapes, trails, whatever you want to call them. The only images I could find of this were CGI images created on a computer. Now, I found this highly puzzling that I couldn't find any real-life examples of this that weren't created on a computer. So then when I look at the moon and I'm asking myself, where are these impact trails, impact ditches, if you will? They simply don't exist. So we have to then at this point, being that science, mainstream science, is telling us that all these impact craters are coming from space rocks slamming into the moon, we have to then ask ourselves, is it theoretically even possible for the moon to be getting hit by space rocks, all of which are entering at a 90-degree angle, to make these circular craters? Because it seems to me, or any logical thinking person, that these meteors, comets, and asteroids are going to be coming in at all sorts of angles, various angles. If the moon is orbiting the Earth, and the Earth is orbiting the sun, and the sun is shooting through space, and all of these unfathomable speeds that they say we're going, that means the moon should be getting hit by space rocks from every angle imaginable, and for it to make only circular craters would be a physical impossibility. So at this point, I will now demonstrate through a actual physical experiment that you cannot physically have nothing but circular craters on the moon if they are all due to impacts. We should be seeing gouges, scrapes, ditches, canyons that are being dug out by sideways, angular, incoming impacts. All right. So today I am out in the country so I can perform an experiment and not disturb anybody at the same time. Today what I want to demonstrate is the different type of marks that a high velocity object making an impact will create. So for instance, if space rocks are said to be smacking into the moon and making those round craters, what I'm going to do today is I'm going to take my air rifle and I'm going to shoot BBs into the earth, the ground right here, and I'm going to shoot the ground at various angles. I'm going to shoot the ground at 90-degree angles, and then I'm going to shoot the ground at all different varying angles so that we can compare and contrast the different impact marks that the BB makes into the ground. And that's going to be my experiment, is just get different types of impact marks from different angles so that I can demonstrate if objects were hitting the moon all day long from space, we should see varying different marks and not just circular impacts, which basically seems like that's all there is on the moon is circular impacts. And there should be different sorts of impacts, like ones that make trails and dig marks. So that's what I'm going to do today, is attempt to make trails and dig marks with my BB gun to demonstrate that if objects are hitting a spot at various different angles, we should see various different sorts of impacts. So I'm just going to use my regular old air rifle. Don't be alarmed. I know it looks like it has a clip, like it might be an AK. This actually holds CO2. It's not a clip. I don't have any CO2, so I'm going to do regular old school pump action. But yeah, you could put CO2 cartridges inside this guy right here, and then you don't even have to pump your BB gun. You can just load it up and fire over and over, which is cool. I used to do that when I was a teenager. I have not shot this gun in freaking years and years and years. Anyway, so yeah, I've got a spot that I actually flattened out, and I'm gonna shoot that spot and make some different sorts of impacts. So first thing I'm gonna do, 3, 4, 5, 6, 7, 8, 9, 10. First thing I'm gonna do is make some 90-degree angles, straight up and down impacts. I've done 2, I'm going to do a third one, and then we're going to look at these impacts that I'm making with straight up and down, trying not to get any angle on it at all, like a 90-degree angle impact. All right. Now let's see what we ended up with. So here's the area that I flattened out. And as you can see, I shot 3 times. One of them made this circular impact crater. And you can even see the BB then popped out. And then the other 2, as you can see, the BBs are still stuck in there, and there's round holes. They made round holes because I shot it straight in at a 90-degree angle. Now, I'm gonna shoot the rest of this area, and as you can see, there's no other marks. I tried to get it nice and flat and take away all the blemishes so we can see the next marks I'm gonna make. I'm gonna shoot now at different angles, and we're gonna see the different types of impacts it makes. So on the first shot, it took a chunk out and made a round crater like you would see on the moon. And then you see these other two where the BB just went straight in. So you can see I was at a 90-degree angle and it makes these holes. So now I'm gonna shoot it, the ground, at various different angles so we can see what type of marks that those leave. And I just got this new handy dandy tripod to shoot this video with. All right. Now I'm gonna shoot the different angles. I can't tell you what angle because I'm just gonna make them up. But if objects are hitting the moon for millions and billions of years, they should be hitting the moon at different angles, right? Not just 90-degree angles. So now I'm gonna shoot different angles into this spot.
All right.
So, here's the spot where I shot multiple different times at different angles. See the difference that this leaves, these impacts that I made when I'm shooting at an angle, versus these ones where the BB is still stuck straight in the ground at a 90-degree angle. Those are circular holes. And then this one made a circular crater right here, like you might see. But at different angles, when I take different angles, you see this made like a dig mark, a little trail. This one took a big gouge out. That one is going inward at an angle. So this is my perfect illustration. If there's these dig marks that I can make with my BB gun at different angles, where are the dig marks on the moon?
I just increased the voltage.